G'day guys, my name is Connor Butcher. Today I will be explaining and demonstrating Kirchhoff's voltage law for you all. First of all, what is Kirchhoff's voltage law, also referred to as KVL? Well, it is quite a simple concept actually. KVL states that the algebraic sum of all voltages within a closed circuit or loop will equal zero. Bit confusing, what does this mean? Well, I'm glad you asked. As you can see here, I've drawn a very simple circuit with a voltage source and two resistors without any specific values. From KVL, we can see that algebraically, V1 minus V2 minus V3 will equal 0, or V2 plus V3 will equal the source voltage, V1. This is KVL in its simplest form. Before I continue, I should note that in a parallel circuit, the total voltage supplied by the source is equal to the voltage across each parallel branch. KVL can be used effectively in conjunction with basic electrical engineering laws, such as Ohm's law. This is why KVL is so useful for solving unknown voltages in all types of circuits. If you turn your attention to figure 1, you will see a very simple series circuit with a voltage source of 12 volts and 3 resistors, 10 ohms, 20 ohms, and 30 ohms respectively. On the right of this same image is a few basic equations to help us solve the respective voltage drops of the circuit. From this, we can then in fact prove Kirchhoff's voltage law. Let me talk you through it. In figure 2, you can see that we first have to calculate the total resistance. Since it's a series circuit, it's just as simple as adding all the resistors together, and from this we get a total of 60 ohms. Easy enough. Now we have the total resistance and a source voltage. We can then find the source current from rearranging V equals IR to be I equals V on R. This will help us find all voltage drops across the resistors. And our current is 0.2 amps. We can then simply use Ohm's law to calculate our voltages of V1, which equals 2 volts, V2, 4 volts, V3 equals 6 volts. You may be able to see where KVL can be used here. We can use KVL to prove that these are in fact the correct voltages. The 3 voltage drops in the circuit should equal the source voltage, which in this case is 12 volts. We could rearrange the equation to equal the source voltage, but in this case there is no need, as we minus the 3 voltages from the source voltage to obtain 0. Therefore, proving Kirchhoff's voltage law. If, for example, our V1 remained unknown, we could then write an equation for it, that being V1 equals Vs minus V2 minus V3. This law can be used in conjunction with so many different concepts such as nodal analysis and voltage divider rule. This is why it makes it such an important law to master. Thanks so much for listening. Have a great day.